Good morning guys and welcome to Mind Your Math. Today our class is on a very easy topic of grade 9, which is the Heron's formula. This formula, as you well know, that it is used to find out the area of triangles when the measure of all the three sides are given to you. Okay. Now this is one of the easiest chapters of grade 9 and it is a chapter that you can study well in advance, and you just need to remember the formula, and there is one chapter that you can actually choose to skip just the day before the exam and focus on the other chapters, because this is a chapter that will stay well in your memory. Okay. Now, if you have any doubts regarding the contents of this particular video, you know where to reach me. The mail ID is given below in the description box. So now let us begin with the class. Before we start doing the Heron's formula, let us first revise the area of triangles, basically the formulas that you have already learned how on finding the area of triangles. Now the very basic one is half of base into height. Now that is a formula that you can use for any triangle as long as you know the height. So what is height? Height is basically the perpendicular drawn from the opposite vertex to the base, if this is the base. So this is my height. Suppose I am taking this side as the base, the height is not this length. The height has to be the perpendicular that is dropped from the opposite vertex to this base. This is the height. Okay. So depending upon the value of the base and the height that is given to you, you can easily use this particular formula in order to find the area. Now, in the case of an obtuse triangle, one thing to note is that the height always falls outside the triangle. Suppose you have a triangle like this. It's an obtuse angle triangle. Okay. Now, suppose you are taking this as the base. If this is the base, the height of the triangle is the distance which is at 90 degree to that particular base. So please note that in certain cases, the height of the triangle also falls outside the triangle. This is one common mistake some students make. So please ensure that you are well aware of this particular fact. Okay. Now, in the case of an equilateral triangle, as long as you know the side of the equilateral triangle, you know there is a formula which is root 3 by 4 a square. Okay. Now, these are the basic formulas, I guess, that you have learned in order to find out the areas of triangles. Now, let us look at Heron's formula and why and when it is used. Okay, you don't have to learn the proof of this formula, so you just need to by heart the formula and then apply it on the numerical. Now, the Heron's formula basically states that the area of a triangle whose sides are given by the measures small a, small b and small c is given by the formula root of s into s minus a into s minus b into s minus c, where a, b and c, as I have already mentioned, are the measures of the sides of the triangle. S is a new term that you are going to learn today, which is the semi-perimeter, which is half of the perimeter of the triangle. Okay. Now this particular formula pretty easy to memorize, and it is also easy to apply on the sums as long as you know the sides of the triangle. The only thing that you need to remember is not to make any calculation mistakes, because this is one formula that involves a little bit of calculation, because it involves root and it involves multiplication, subtraction, everything together. Okay. Now, the semi-perimeter is a new term that you are learning now, which is the sum of the measures of the sides, which is the perimeter divided by 2. Now that you are learning the Heron's formula, I also want to mention another formula. Okay, this is absolutely not applicable for your Cbse syllabus, but just I thought I would mention it because it is a formula which is very similar to the Heron's formula. It is called as Brahmagupta's formula. So in case you need it for any competitive examinations, you can always memorize it. It is given by Brahmagupta's formula is given by s minus a into s minus b into s minus c into s minus d under the root. Now, the question comes, where are we going to apply this formula? This formula is applicable only to cyclic quadrilaterals. Now, what is a cyclic quadrilateral? I will just make a mention of it. A cyclic quadrilateral is a quadrilateral that can be inscribed inside a circle. Okay, so Brahmagupta's formula is root into S minus A into S minus B into S minus C into S minus D, where A, B, C and D are the measures of the sides of the cyclic quadrilateral. And when the value of one side, let us say D, becomes 0, it becomes Heron's formula. Suppose this side D was not there, this would become a triangle, right? So D is 0, this became Heron's formula. Now you don't have to take the trouble to remember Brahmagupta's formula. If you are not interested in learning extra, just remember Heron's formula and apply it to the sums. Okay. Here is our first sum. Find the area of a right triangle whose sides measure 5, 12 and 13. So we know that there is a right triangle which is given to you, and 5, 12, 13. Okay. Or 5 and 12 can interchange, but then 13 is definitely the hypotenuse. Now, first thing is that whenever you are asked to find out the area of a right triangle whose 3 sides are given or 2 sides are given, when 2 sides are given, you can definitely find the third side by using Pythagoras theorem. When it is given to you, unless specifically mentioned in the question to use Heron's formula, never ever use Heron's formula, because it can very easily be found by using half base into height, because this is always at a 90 degree. So this side becomes the height. But if they are specifically asking you to use Heron's formula, you have to use it. But unless it is specifically mentioned, please always go for half into base into height. Don't just, in the rush, apply Heron's formula and waste your time. Now, let us find out the area of this particular triangle. It is given by half into 5 into 12, which is 30. Okay. Now, let us say this is in centimeters. So this becomes centimeter square. Now let us find the area of the same triangle by using Heron's formula, so that you get an idea on how to use Heron's formula, and let us see whether we are getting the same value for the area. Okay. Okay, so now I have written here the steps for finding out the area using Heron's formula. I have first found the semi-perimeter given as S. S is equal to sum of the sides divided by 2, which is I will get 15 centimeters. Now because this is a perimeter, the unit is centimeter. Okay. Now semi-perimeter is again, it's a perimeter itself, so it is 15 centimeter. Now area is S into S minus A into S minus B into S minus C under the root. So 15 into, I have mentioned it over here. Now this is what I am getting, 15 into 10 into 3 into 2. Now many of the students, when they are actually calculating the square root, what they do is that they multiply all these terms together and then try to find out the square root by using prime factorization or similar methods. Okay. It's a procedure. You will get the correct answer, but it is a procedure that will take up, a little bit of time. Now, when you are trying to save time during a maths examinations and you want to find the square root, here itself split it into prime factors. 15 is 3 into 5, 10 is 5 into 2 and 3 and 2. And for every 2 factors, take out a single factor. That is how you find out the square root. So, I have 2 3's, there is a 3, 2 5's, there is a 5, 2 2's, there is a 2. So, I get the value as 30 centimeters square, exactly the same value that I found by using half into base into height. Okay. So, now you are clear with how to apply Heron's formula whenever a triangle and its 3 sides are given to you. I also mentioned that when it is a right triangle and nothing else is mentioned in the question about Heron's formula, please use half into base into height. Okay. And also another thing is that under the square root, do not multiply all the terms together in order to get a big value over here. Try to simplify it in the beginning itself by splitting it into each term into its prime factors. Okay. Now let us proceed with a few more sums and see how Heron's formula actually works. So now we have the second sum over here, which is find the area of a triangle whose sides measure 18 centimeters and 10 centimeters and the perimeter is 42 centimeter. So here you have a triangle 18 and 10. We don't know the third side, but perimeter is given to you, which is 42 centimeter. Perimeter, as we know, is the sum of the measure of the sides. So now we know the measure of all the 3 sides. We know the value of perimeter. So we can find the value of S. The value of S is given as 42 by 2 semi-perimeter, which is equal to 21 centimeters. Now let us apply Heron's formula, which is S into S minus A into S minus B into S minus C. I am not repeating the formula, but you need to write it every single time you are doing a Heron's formula sum, because you need it for the examination. Okay, formula is very much required. So here I have 21 into 21 minus 18 into 21 minus 10 into 21 minus 14 under the square root. Okay, so here you have 21 into 3 into 11 into 7. Okay, as I told you, I will be splitting it into prime factors. So 7 into 3 into 3 into 11 into 7 under the root. I have 2 7s, I will take out a single 7. I have 2 3s, I will take out a single 3. But I have got only 1 11, so I will keep it still under the square root. So my answer would be 21 root 11 centimeter square. Okay. Now, in certain cases, the value of root 11 will be given to you in the question. Okay, root 11 is equal to so and so value. If the value of root 11 is given to you in the question, they are expecting you to multiply this 21 with the value of root 11. So, as a final answer, whatever be the value of root 11 that is given to you, you have to multiply it and write the final answer. If the value of root 11 is not given to you, you can leave the answer over here. The sides of a triangle are in the ratio 12 is to 17 is to 25 and the perimeter is 540 centimeter. Find the area. Okay. So now, in this case, the sides of the triangle are not directly given to you. So they have been given in a particular ratio, but the perimeter is given to you. So the perimeter is given to you, which means that you can find out the measures of the individual sides of the triangle. So since the ratio is given to you, let us take the measure of the triangle as 12x, 17x and 25x. Okay. Now the sum of all the three is 540, which is the perimeter. Now from this we can find out the value of x. So here you can see that all the three add up to 54x and that is equal to 540. So we can find out the value of x and that gives us 10. Now we can find out the value of the measure of individual sides of the triangle, which is 12x becomes 120, then 170 and 250. Now that you have got a measure of all the three sides of the triangle, now we can start with Heron's formula. The first step is to find the semi-perimeter. Perimeter was already given to you. So semi-perimeter becomes 270 centimeters. Okay. Now let us apply Heron's formula. Area of the triangle will be S into root of, obviously, S minus A, S minus B, S minus C. Okay. So here you get S into 150, here you get a 100 and here you get a 20. Okay. As I told you, it is better that we split each of the terms into its individual prime factors. So let us see what we are getting. Here I have shown you how I have split each term into its prime factors. 270 is 9 into 3, 27 into 10. I have retained 10 as such because I have figured out that I can pick out 10, so many 10s from inside the square root. So 27 into 10 becomes 3 cube into 10. Okay. Now 150 is 5 into 3 into 10 and 100 is 10 square and 20 is 5 into 2 square. So inside the bracket, I will be getting that term. Now I have 3 cube and one more 3. So I have 4 3s. So out of that I am picking out 2 3s outside. So becomes 3 square. Now I have got 2 10s and 1 10 square, which means that I can pick out 2 10s. So I will be getting 10 into 10. 2 5s, 5 comes out and there's a 2 square inside the square root, so a 2 comes out. And the final answer is 9000 centimeter square. The sides of a triangle measure 28, 30 and 26 centimeters. Find the height of the triangle to the smallest side. So here you have a triangle of whose sides measure 28 centimeter, 30 centimeter and 26 centimeter. We need to find the value of h to the side 26 because that is the smallest side. Okay. So the basic concept over here is that the area of the triangle will remain the same in whichever way we are finding out the area of the triangle. Whether we are finding out the area of the triangle using the Heron's formula or by using the formula half BH, the area is going to remain the same. So the area if you find out the area by Heron's formula will be equal to half into base. I have taken the base as the smallest side because this is the h that we need to find into h. Now here I have found out the semi-perimeter, which is 84 by 2, which is 42 centimeters. Then I have found out the area by using Heron's formula. You can see that I have split up each term into its prime factors here itself instead of multiplying all the terms and then finding out the square root. So this is what I am getting. I will be taking out a single term for every two terms that I am finding. So here I will be getting the area as 336 centimeters square. Now after getting the area as 336 centimeters square, I am going to equate it to the value of half into 26 into h. And let us see what we are getting. So you can see that I have equated the area to half into 26 into h. I am getting the value of h as approximately 25.85 centimeters. Okay. A rhombus shaped field has green grass for 18 cows to graze. If each side is 30 meters and the longer diagonal is 45 meters, how much of grass field will each cow be getting? Now this is a sum from the NCERT textbook. You are given a rhombus shaped field. So you know in a rhombus all the sides are equal. So it is 30, 30, 30, 30. So they are telling that the longer diagonal is 48 meters. You know that the diagonals of a rhombus are not equal to each other. So let us randomly mark one diagonal be 48 meters. Okay. So we need to find how much of grass field will each cow be getting. So there are 18 cows. So in order to find how much of grass field each cow will be getting, we need to find the total area and then divide by 18. Okay. So in order to find the total area, we need to see the diagram. We have got a rhombus which we can easily divide it into two triangles, or you can either mark this also as a longer diagonal. You will still be getting the same value because all sides of the rhombus are equal. So this is triangle 1 and this is triangle 2. To find out the area of triangle 1, you have got all the three sides which is the same as the sides of the triangle 2. So you just need to find out the area of one triangle and multiply it by 2. Okay. Now that is by applying Heron's formula. So let us see what is the value of area that we are getting. I have found out the semi-perimeter by adding the three sides. So I am here finding out the area of the first triangle, which is this. Okay. So the sides are 30, 30 and this is 48. So I am getting the semi-perimeter as 54. I am finding out the area of the triangle 1 by using Heron's formula. So I have split up into prime factors and here I am retaining 24 as such because I have got two 24. So I can directly take out a single 24. So I am getting the value as 432 meters square. That is the area of one triangle. I have two triangles. So what is the total area? So it is 432 into 2, which is 864 meters square. So 864 meters square is the total area that is available for 18 cows to graze. So in order to find the value of the land that is available for a single cow to graze, I have to divide the total area by 18. So 864 by 18. So I will get the value as I will get the value as 48 meters square. Okay. So what did we actually do in this sum? We had a rhombus shaped field. There was a diagonal that was given to you. So when you draw the diagonal, it divides the rhombus shaped field into two parts. You can see that the sides of both the parts are equal. So which means the area also will be equal. I found out the area of one side by using Heron's formula and I multiplied it by 2 in order to get the total area of the rhombus shaped field that was available for 18 cows to graze. In order to find the area for one cow, I divided by 18. Okay. Now this is how you find out the area of this particular field by using Heron's formula. Now in the question, suppose there is no mention of Heron's formula. There is another formula that you can easily apply in order to find out the area without resorting to so much of calculations, which is by using Pythagoras theorem. Okay, so how do you apply Pythagoras theorem in this particular form, in this particular sum? You have a rhombus shaped field, right? This is the first diagonal. This is 48. Suppose this is 48. There is another diagonal which goes like this. You know that the diagonals of a rhombus bisect each other at right angles, which means that at this particular point, the angle is 90° and this side is equal to this and this is equal to this. So if the entire length was 48, each would be 24. You know this is a right angle triangle. This is 30 and this is 24. You can easily find out the length of this particular side. So let us see what we are getting as the length of this particular side by using Pythagoras theorem, which is 30 square minus 24 square. Okay. You can see that you will get the length of this part as 18 meters. Okay. Now you have got a right angle triangle whose base is 18 and whose height is given by 24. How do you find out the area? You will find out the area by using half into base into height. So the area of this triangle is half into 24 into 18. Correct. Now, after finding out the area of this triangle, you can see that the measurement is the same for all the 4 triangles. So, I just need to multiply this particular area by a quantity of 4 in order to get the area of the total rhombus shaped field. Okay. That is an easier way of finding out the area of the rhombus shaped field rather than resorting to Heron's formula. Less calculations involved. But if your teacher or if your question paper particularly insists on using the Heron's formula, or your teacher tells in class if a sum in area comes, please use Heron's formula, please go for our Heron's formula itself. Okay. Otherwise, apply Pythagoras theorem, get the sides and find out the area using half into base into height. So this is our next question. There is a kite which is given in the shape of a square and it has a small base which is also in the shape of an isosceles triangle. In the question, the measurements of the isosceles triangle, it is given to you. It is 8 cm base and 6 cm sides. And in the case of the square, they have given you only the diagonal. Actually, square is a very versatile kind of diagram. You need the side, you only need the diagonal. It's very easy to find the area. Okay, so now they want you to find how much paper of each shade is used. So basically in the question what they are telling is that this particular triangle, which is our first triangle, it is of one shade. This is the second triangle which is of the second shade and this isosceles triangle is of the third shade. So in each case, since the different shades are used, we need to find the area of each part separately. Okay. Now this particular part, no big deal. You can find it using Heron's formula. Okay. So this part is set. We will find it using Heron's formula. Now, you know that the diagonal of a square are always equal. Okay. So if this is 32, this part is also 32. And also the diagonals of a square bisect each other at right angles. So this is a 90° and this part is 16 and this part is also 16. The total measure being 32. Similarly, this part is also 16 and this part is also 16. So 16, 16. So now let us see the methods in which we can actually find out the area of this particular shape. Okay. Now, so now here you know that the diagonal of a square is root 2a. A is the side of the square. This is equal to 32. So what's the value of a? The value of a is 32 by root 2. Now you know the area of a square formula. The area of a square is given by a square. So a value you know. So 32 into 32 divided by root 2 square is a 2. So you will get 16 into 32, which should give you 512 centimeter square. So you have gotten the value of the whole area as 512. You know that this particular diagonal is bisecting the shape into two equal parts. So the first part will measure 256 and the second part also will measure 256. Okay, that is one way of finding the area of the square. So let us try out another way. You know that for this particular triangle, this is the base and this is the height because the diagonal is always at a 90° over here. So what is the area of the first triangle? The area of the first triangle is also given by half into base into height, which is half into 32 into 16, which will give you 256. Correct? That's the area of the first triangle. It will be the same area for the second triangle also. So this is also 256. So whichever way you want to find out the area of the square, you are free to do it. Just make sure your calculations are correct and the formulas that you are using, they are also correct. Okay. Now the third part, as I have already told you, you can find out the area using Heron's method. Okay. So I am not going to do the calculations. It's a pretty easy calculations. So you can do it by yourself. I have just explained the methods in which you can find out the area of the square. A field is in the shape of a trapezium whose parallel sides measure 25 meters and 10 meters. The non-parallel sides are 13 meters and 14 meters. Find the area. So here you are given a field which is in the shape of a trapezium. So what is a trapezium? A trapezium is a four-sided figure having at least one pair of parallel sides. Okay, the other pair are non-parallel. So when I am saying the other pair of sides, they are non-parallel, then the question arises as to the length of those sides. So a trapezium, the most common trapezium is a figure something like this. Okay, these are the two parallel sides. Now this and this are the non-parallel sides. So whenever we are talking about a trapezium, we need to understand the length of the non-parallel sides in order to understand the type of trapezium that is given to you. So if the two sides are equal, it is called as an isosceles trapezium. Okay. If these two sides, they are unequal, it is called as a scalene trapezium. Now, in a particular case of trapezium, you will have one angle at a 90 degree, this being the parallel sides. This type of trapezium is called as a right trapezium. Okay. In this particular question, since the non-parallel sides are of length 13 and 14, we are talking about a scalene trapezium. But since I am introducing you to the scalene trapezium and how to find out the area of a scalene trapezium, I will also tell you how to find out the area of an isosceles trapezium, which is the easiest kind of trapezium wherein you can divide it into proper triangles and rectangles. Okay, so let us see how we are going to do it. So here you can see that I have given you a question which is having an isosceles trapezium. So we have two parallel sides which measure 20 meters and 10 meters and the non-parallel sides are 13 meters each. So let us see how we can do this. So we have a trapezium here. So this is given as 10, this is given as 20. Now this is 13 and this is 13. So normally to find out the area of a trapezium, what do you need? You need the formula which is half h into a plus b, where is half into h into a plus b. Correct. What is h over here? H is the height of the trapezium, which is at, this line is at 90 degree to the base. This is the height of the trapezium h. Now a and b, this is a and this is b. Okay. Now in this case, we do not know how to find the value of h. Now let us figure out whether we can find out the value of h or whether there is any possibility for us to apply the Heron's formula, or can we find out the area without applying Heron's formula. So if you are dropping another perpendicular from here, this is also h. Correct, because these are two parallel lines. The difference in the height between the two parallel lines at any point will be the same. So if this is h, this is also h. Now as you can see that two lines at 90 degrees and two parallel sides, this becomes a rectangle. Correct. So if this is 10, this also has to be 10. Out of this 20, this 10 has gone to the base of the rectangle. So what is remaining? Remaining of 10 meters are pending. That 10 meters, because it is an isosceles trapezium, it will be divided equally between this side and this side. It happens only in the case of an isosceles trapezium, not in the case of a scalene trapezium. So if this part is x, this part is also x. 10 meters will be equally divided between this and this. You know that this is a right angle triangle, this is a hypotenuse and this is a base. So how can you find out the height? H is equal to hypotenuse square minus base square under the root. This is 12. So the value of h is 12. Okay. So how do you find out the area of the trapezium over here? You can directly apply the formula half h into a plus b over here. That is the easiest way to find. Now this is how we would find out the area of an isosceles trapezium. As you can see that we did not need the Heron's formula at all over here. Okay, so now let us see how to find out the area of a scalene trapezium. Whether we can apply the same method as here or whether we should resort to another method is something that we will see when we are doing the sum. So now getting back to the previous sum of the scalene trapezium, the sides are non-parallel sides are 13 meters and 14 meters over here. I have drawn the scalene trapezium over, you can see I have drawn the scalene trapezium. Now, if I am dropping a perpendicular over here, I will get a rectangle just like in the previous case. Correct. So, this is 10 meters. So, what is remaining? The whole thing is 25 and this is 10. So, 15 meters are remaining. In the case of an isosceles trapezium, it was equally divided between the bases of these two triangles. But in this case, because the hypotenuses over here or the sides of the triangle are different, it will be unequally divided. So, which means that if this is x, this will be 15 minus x. Now we have a problem. The problem is that we do not have just one unknown h. This is not our only unknown over here. We have another unknown which is x over here. See, doing the calculation we can definitely find out the value of h. I will tell you how. This is a right angle triangle. H square is equal to hypotenuse square 14 square minus base square. Also from this triangle h square is equal to 169 minus the base square. You have two equations and you have two unknowns. We can find out the value of h, but the problem is that this particular method will take a lot of calculations, and if by any chance you are ending up with a fraction for x, then it is going to be really difficult in order to find out the value of h using this method. So, unlike the case of an isosceles trapezium, what I would suggest is that use another method so that we can find, you can have easier calculations. In finding out the area or any sum that is involving calculations, it is always better to adopt a method which involves lesser calculation. If any of you want to try it out using this particular method, just like in the case of a scalene isosceles trapezium, please feel free to do so, but then see the difference in time that you are taking in the other method and this particular method and decide which one you want. So let us see another method in which we can find out the area of this particular diagram. So this is our trapezium. So instead of trying to convert it into rectangles and triangles, I will be trying to convert it into a parallelogram and triangles. Now I'll tell you why exactly. So first let me construct the parallelogram. I will draw a line parallel to the side that measures 13 or the side which is shorter in length. Now, why cannot I take a side which measures longer in length? If this is the trapezium, this is 13 meters and suppose this is 14 meters and I am trying to draw a line which is parallel to 14 meters, you can draw, but also measures 14 because in a parallelogram opposite sides have to be equal. This will fall outside the diagram. Take the side which is shorter in length. This is 13 meters. Now, this is 13. This is 13. This side and this side are parallel. This side and this side are parallel. By construction, it becomes a parallelogram. In a parallelogram, opposite sides are equal. So, if this is 10, this part is 10. So, what is remaining in the base of this particular triangle? 25 minus 10, which is 15, is remaining. I have now divided this particular diagram into two parts, which is a parallelogram and a triangle. Okay. Now, how do you find the area of the triangle? The three sides are given to you. You can find it out using Heron's formula. Our problem is we do not know how to find out the area of a parallelogram because the formula for the area is base into height. You know the base, but you don't know the height. So, where does the height of the parallelogram fall? This is the height of the parallelogram, or this is also the height of the parallelogram. If you have a parallelogram like this, the height of the parallelogram to this particular base is either this or this. Okay. So, this height of the parallelogram also becomes the height of the triangle. So, how can you find out the height or how can you find out the value of h over here? This is h. This is also H. Find out the area of the triangle using Heron's formula. You know that whichever method you are finding out the area of the triangle, the value of the area will remain the same. So, area of the triangle using Heron's formula is the same as half into base into height. Okay, what is our base over here? Base is 15. Half into 15 into H. This H is not only the area of not only the height of the triangle, but it is also the height of the parallelogram. So find out the area of the triangle using Heron's formula. Equate it to half into base into height in order to find out the height of the parallelogram, and then find out the area of the parallelogram using base into height. Okay, so now you have understood why I have divided this particular diagram into a parallelogram and a triangle. We have used a parallelogram as our basic construction diagram. The reason being, we can easily get the third side of the triangle. Okay, so now let us do the calculation and see what we are getting. So here I have done the calculations. I have found out the area of the triangle using Heron's formula. First, I have found out the semi-perimeter, 21 meters. Then I have applied the formula over here. But when you are writing for the exam, please ensure that you are writing the complete formula. Okay, even for the semi-perimeter, which is a plus b plus c by 2, and the Heron's formula, which is root of s into s minus s, so and so. I have found out the area. Here you can see that I have split it into prime factors over here itself, and I have found out the area of the triangle. Now area of this particular triangle is also equal to half into base into height. I have equated and I have found out the value of height over here. Because this is not a proper value, it is a decimal, I have left it as a fraction itself, and I have found out the area of the parallelogram using base into height. So I have got it as 112. So the area of the entire field will be the sum of 112 and 84. Okay. So whenever you are getting a quadrilateral in a particular shape, try to convert it into usable shapes. So it can be a rectangle, it can be a square or a parallelogram. So depending upon the diagram, please ensure that you opt for the method which involve the least bit of calculations. Okay.